When you hear the word serotonin, your mind probably jumps straight to the happy chemical, right? You know, the stuff in your brain that regulates your mood. But what if I told you that's only like 5% of the actual story? Today, we are diving deep into the hidden world of serotonin, the part that almost nobody talks about, but is secretly running some of your body's most critical systems.
Okay, get ready for this number, 95%. That is a staggering amount. That's how much of your body's total serotonin is found outside of your brain. Just let that sink in for a second. 95%?
So, if it's not in your head, where in the world is it? And, what is it even doing? That is exactly what we're here to figure out. We're about to uncover this huge, totally separate universe of what scientists call peripheral serotonin.
All right, first, a super quick definition. Serotonin is a bioamine, and it's made from an amino acid called tryptophan. Now, the most important thing to get here is that it has two completely different jobs, and it all depends on where it is. Up in the brain, it's a neurotransmitter, passing signals between nerve cells. But in the rest of your body, it acts like a hormone, traveling through your blood to boss around your organs.
This image here shows exactly how the body keeps those two jobs from mixing. So, you've got the periphery, or the body, on the left, and the brain on the right. Notice they use different starting blocks, different enzymes. It's TPH1 for the body and TPH2 for the brain. And that dotted line running down the middle, that's the blood-brain barrier. Think of it like a maximum security wall that makes sure the serotonin made in your body can't sneak into your brain and vice versa. They are two totally separate, isolated systems.
So now that we've established that separation, let's go on a little tour of your metabolism and see how this other 95% of serotonin actually works. We're going to follow it on its journey and see how it pulls the strings on your body's energy supply.
This diagram is basically our map for the whole tour. It shows all the key players. And our story really starts in the gut. That's where these special cells, called Enterochromaffin cells, crank out the vast majority of this peripheral serotonin. From there, it gets into the blood. But, as you can see on the slide, only about 2% of it is actually free and able to act like a hormone, sending signals out to all these different organs. So let's go visit them one by one.
Our first stop is the pancreas. This is the master regulator of your blood sugar, mainly because it makes that critical hormone, insulin.
Okay, so inside the pancreas, serotonin's role is super localized. Get this, the pancreatic beta cells, they can actually make their own serotonin. And this little local supply, it acts on the very cells that made it. It's kind of like talking to yourself to get a job done. And its job is to help push out insulin. It's also really crucial for helping the pancreas grow and adapt during pregnancy.
All right, next up on our tour, the liver. This is your body's central command for fuel management.
When serotonin from the gut arrives at the liver, it delivers a very specific message. It basically says, hey, we need more sugar in the blood, stat. It kicks off a process called gluconeogenesis, which is just a fancy way of saying making new glucose, and at the same time, it tells the liver to stop taking up so much glucose. It's all about making sure there's enough fuel available for the rest of the body.
And for our last and honestly most fascinating stop, we are heading to the adipose tissue, what you and I just call body fat. This is the fat controller.
And this is where things get really interesting. If you look at our map, you'll see serotonin interacts with two different kinds of fat. White fat, which is for storing energy, and brown fat, which actually burns energy to create heat. And just like the slide says, it plays this kind of double game with completely opposite effects on each one.
Let's break that down. In white fat, over on the left, serotonin encourages lipolysis. That's the breakdown of stored fat to release energy for the body to use. But then, in brown fat on the right, it does the exact opposite. It suppresses thermogenesis, which is the process of burning fat to make heat. So it's telling one type of fat to release fuel while telling the other type to, well, chill out and conserve it.
So we've seen how it all works, but why does any of this metabolic meddling really matter? Well, this is the big payoff. Understanding this system opens up a completely new way of thinking about how we treat metabolic diseases, like type 2 diabetes.
This quote from the research is pretty powerful. Scientists found that in obese mice with insulin resistance, the amount of serotonin in their blood was over 7 times higher than in healthy mice. That's a huge clue that having too much of this peripheral serotonin might be a key driver of the problem.
And that discovery immediately leads to this really groundbreaking question. I mean, if these high levels of the hormone are causing all these metabolic issues, what would happen if we could just turn down the production line, but only in the body? Well, the answer might lie in a class of drugs called TPH1 inhibitors. Remember TPH1? That's the enzyme that makes serotonin out in the body. These drugs are designed to block just that enzyme. And here is the absolutely brilliant part. They do not cross the blood-brain barrier at all. This means you could lower the body's serotonin without ever touching that happy chemical supply up in the brain. It's like a surgical strike.
And the results from animal studies have been just incredibly promising. When they gave these inhibitors to diabetic mice, they saw better insulin sensitivity, lower blood sugar, lower fats in the blood, and they even started burning more energy. It's like a total system reboot.
All of this brings us to the future of how we look at this amazing molecule and why it is so important to start thinking beyond the brain. Look, if you remember one thing from all this, let it be this. That massive, ignored 95% of serotonin isn't just hanging around doing nothing. It is a powerful hormone, a master regulator that is fundamentally controlling how your body manages and spends its energy.
And that leaves us with one last, really fascinating question to think about. We've seen the potential for treating diabetes, but if we can manage metabolism by targeting this system so precisely, what else might it be controlling? Research is already hinting at its role in inflammation, bone health, and a whole lot more. So you have to wonder, what other secrets is this hidden world of serotonin waiting to reveal?